Properties of whole numbers for subtraction. Let us see the basic properties of the whole numbers for subtraction. So as we know already, the closure property, commutative property and associative property. Along with that, existence of identity and inverse. Let us check in this whole numbers for subtraction. So when you come to this closure property, first one. So as per this rule, if x and y are two whole numbers, then x minus y is not necessarily whole number always. So it's not necessary every time. So that means x comma y belongs to whole numbers. Every time x minus y may or may not belongs to whole numbers. Maybe sub whole numbers or not. Let us check one example. We know that 4 comma 2 or belongs to whole numbers 4 and 2. From this 4 minus 2 is equals to 2. This also is whole number. Or else 7 and 11 or the whole numbers. From this 7 minus 11. 7 minus 11 is minus 4. But it's not belongs to the whole number. That means one thing we can conclude. If x and y are two whole numbers, then x minus y is not necessary a whole number. Right? So, and that means the whole numbers are not closed for subtraction. So they're not closure properties does not exist for the subtraction. Next one, commutative property. So when you come to this commutative property, here is if x and y are two whole numbers, then if x comma y are two whole numbers, then x minus y is not equals to y minus x. This implies the subtraction of two whole numbers is not commutative. Check with example. Let us take 15 comma 8 are two whole numbers. So 15 minus 8 and 8 minus 15 is both are not equal because 15 minus 8 is 7 and 8 minus 15 is minus 7. So they are not equal. That means the subtraction of two whole numbers is not commutative. Right? And when come to this associative property. Next one. Yeah. Associative property. Here is a three numbers. That is, if any three whole numbers, let us say x, y, z, or belongs to whole numbers, check once x minus y minus z and x minus y minus z. So they are not equal here. So that is the subtraction of whole numbers does not satisfy the associativity. Even for this, let us take one example. In the place of x, y, z, okay, for x is equals to 10, any number, let's take bigger number then. X is equals to 15, y is equals to 10, and z is 7. So as per the rule, x minus y minus z is not equal to x minus y minus z. Both we can check that we get same answer or not. First, x minus y minus z, that is 15 minus 10 minus 7. 15 minus 10 minus 7 is 3. 15 minus 3 is 12. This we got 12. Next one, x minus y minus z. So 15 minus 10 minus 7. 15 minus 10 is 5 and minus 7, that is minus 2 because 5 minus 7. So here is a small number, big number is subtracting, so negative 2. They are not equal. That means we can conclude that the subtraction of the whole numbers does not satisfy the associativity. Right. And next one we have the identity and inverse. Let us check is exist or not. So first one, identity. When you come to this existence of identity for any whole number x, if x is belongs to whole number, then x minus 0 is equal to x. But 0 minus x is equals to minus x. 0 minus x is minus x. So for this subtraction, no identity number exists. X minus 0 is not equals to 0 minus x. Not equals to 0 minus x. So existence of identity. That's why subtraction has no identity number for this. And existence of inverse. We come to this inverse. Since subtraction for every non-zero whole number does not have identity number, so its inverse also does not exist. If there is no identity, then inverse also not exist directly. So there is no inverse for this, right? So overall for subtraction, when you observe, the closure property, commutative, associative, and identity and inverse or not exist for this. These are the properties of the whole numbers for subtraction. Let us see the multiplication for